Hi, I'm Heati and today I would like to talk about pressurization units. Maybe you're asking yourself, what is the pressurization unit and why I'm seeing an air handling unit on the screen? Well, my dear friends, the air handling units are using heat exchangers to control the air temperature, and some of these heat exchangers are using boilers to heat the heating agent and to control the pressure into a heating installation, sometimes using pressurization units, unlike in a domestic application where we can pressurize the unit manually. In a commercial environment, we have to make sure that the pressure, the heating system's pressure, it is monitored. Now let's talk about pressurization unit. What are they and where we use them? Pressurization unit looks like a metal box, but this metal box have a lot of parts inside. It is connected to the main water supply, and you'll use obviously an isolation valve in case you want to remove it or repair it. Also, pressurization unit have an overflow, and I'll explain to you why. The water fill pipe will be connected to the pressurization unit, and it will have a valve in case you want to remove it. Also, pressurization unit have a bypass. In case it will get faulty, you have to fill the system manually. Now, what this pressurization unit have inside? On the top is got a printed circuit board, and if you look below, it is a water tank, and under the water tank you have two pumps. Those pumps are controlled by the printed circuit board, which have a software that allows you to use your own set points, the pressure you want to charge the system, and the alarms that monitor the pressure into the system. Now let's build our heating system. Here's your pressurization unit. When you start installing a pressurization unit, before you connect it to the mainstream, you have to make sure that you will attach to the system a pressure vessel, and I'll explain to you later on why the pressure vessel it is so important. Obviously, because we're talking about a heating system, we have to fit into the system a boiler, which is the heart of the heating process. To transfer the heat, the boiler needs pipes and a pump to circulate the heating agent through the heating system. As you will see in this picture, the pressurization unit pipes, it is connected to the heating system main pipe. Now let's continue to build our heating system. After we finish the pipes, we install the radiators. Guys, please be careful. The installation can be larger. I use this simple installation for you to understand easy what I am doing. Now I would like to clarify a thing. When you install first the pressurization unit water tank, it is empty. The tank have a floating valve which allows the tank to fill up. It acts like the valve you have on your toilet at home. When it fills up, the bowl will be lifted by the water and you will restrict the water to go into the tank. In case that valve will be broken, there is an overflow which allows the water to get out. Now let's turn on the main water supply and allow the pressurization unit's tank to fill up. While the tank is filling up, we have a good chance to observe if we have any water leaks. Now we made sure we don't have leaks, the pressurization unit tanks is filling up, everything is okay, we can put the lid back. After we sorted out the pressurization unit, it is time to open all the relevant valves onto the heating system. Because you don't want to stress the pressurization unit's pumps, when you fill the system for the first time, you will use the bypass. You will see on this small footage that the bypass valve are pulsing, they changing from yellow to red. Also, the purge valve is pulsing, you have to open the purge valve to complete the water circuit. You'll hear the air eliminator working for a while, and they will work until the entire amount of air will be eliminated from the heating system. Once your system will be charged, you will turn off the bypass, and then you will turn on the pressurization unit, which will take over. You can program the pressurization unit, and in this case the pressurization unit will run until the water pressure will reach the set point. That will be a set point chosen by you accordingly to your system design requirements. Don't rush to enable your boiler. First, run the pump. Allow the entire quantity of air to be eliminated. You might have some pockets of air into the installation. Check for leaks. Check the air eliminators. Check the pressurization unit. Check the pumps. Check the pressure vessel. By the way, I forgot to tell you, the pressure vessel should be pressurized to the right pressure. So check everything, and when you will be satisfied, then you can enable the boiler. While the temperature will increase, the heating agent will also increase its volume. And if the volume cannot be increased, then the pressure will raise. That's why we will use pressure vessels to allow the heating agent to expand. It is very important to choose the right pressure when we set up the pressurization unit, and it's also very important to pressurize the pressure vessel rubber bellow inside correctly. Otherwise, bad things can happen. If you are unlucky enough to have a bad pressure vessel because of the rubber bellow blow up inside, when the system is heating up, the pressure will be increased. And if you look into this situation, the PRV near the boiler, you see is changing the color between yellow and red. It can only sustain 3 bars, and the pressurization units show 3.5. That's why the pressure release valve allowed the water to go out of the system, and to one point the pressure will be balanced because you lose enough water. The problem it is in the nighttime when you turn off the unit, the heating agent will cool down, so the volume will shrink. Then the pressure will drop, but it will drop below the pressurization unit set point, and the pressurization unit will run the pump until the pressure will reach the minimum pressure which is set by you. In our case, I put 0.8, but it shouldn't be necessarily 0.8. It's up to what type of installation do you have. So the pressurization unit will push, in this case, 0.8 bars. The problem it is in the second day when you'll reheat the heating agent, you will lose again a quantity of heating agent until the pressure will stabilize just below or equal to 3 bars. So this is a bad thing, and this is why you should be very careful when you design an installation and calculate its volume. So please pay attention to this situation. You will see now the pressurization unit shows 3.5 bars. And if you look near the boiler, the pressure relief valve, which is a PRV, it can support only 3 bars. So because the pressure tried to raise above the 3 bars, the pressure relief valve will allow a quantity of heating agent to be evacuated from the system to protect the system against the extra pressure. So that will flood the premises, you will flood the service floor, the plant room, and if the technician is not coming in time and is not knowledgeable, once he will arrive or she will arrive to the premises, it will only observe just some water on the floor, because by the time they arrive, the pressure relief valve eliminated enough quantity to bring the pressure down to 3 bars. and everybody will think that there was an accident or something happened. And I'm telling you this because I experienced this. I worked for Marks and Spencer for about 10 years, and I have so many situation in which technician turned to the premises and he said, look, there's some water onto the service floor, but I don't know how, maybe the PRV is broken. No one considered this elasticity factor of the installation. In this case, the boiler is running the boiler is running, and the system, the heating agent, it is hot, but as I said, the extra volume has been already eliminated by the PRV. The problem, as I said just before, it is when the system goes off, because the heating agent pressure will drop a lot because the volume will shrink, and the pressurization unit will try to compensate, and by compensating the pressure will bring back the volume which was lost when the system was running. So you have to be really careful how you design the system. We really have to pay a lot of attention with this elasticity. We have to pressurize the pressure vessel with the right amount of pressure, and also we have to choose the appropriate pressure vessel. We have to make sure that the pressure vessel can allow the heating agent to expand, and in this way will avoid having an increase in pressure into the system. So by choosing the right pressure vessel, we can keep the pressure variation of the system under control. Thank you very much. See you next time.